Chapter 2. What is in Chapter 2? It's mainly descriptive statistics. You're going to learn, guys, in Chapter 2 how to organize data and how to summarize data. We won't be making any inferences or making conclusions, straightforward questions and learning how to organize data. So the first page, guys, summarizes the entire chapter. So as I get things done in that chapter, I'll just come back and put some definitions in there. So I'm just going to go to the first section. Let me show you what the section is. Right here. It says, that should have been on the next page, but I don't know how it's shown up here. Section 2.1, frequency distribution tables and histograms. Probably you learned about tables, you know about tables and histograms, but you're gonna have an experience in how to construct such a one. All right. Let me tell you the purpose of using tables. It's just to have a nice display for data. I mean, look at this data set, guys. It's a 30 values. It's amount of utility bills that 30 homeowners pay. Well, I exaggerated here, guys. I know it's a lot more than 40 or 30 or $20. We pay a lot more nowadays, but let's assume it is the case. I want to organize this data. If I don't organize this data and I ask you guys a questions, how many bills are between $35 and $40, it's not going to be easy for you to figure out the answer, because you're going to have to check from the first value to the last value and see how many are there between 35 and 40. So imagine you have a data set that is the size of this table at this page and have hundreds of pieces of data. How could you answer questions like that? You wouldn't. So it's important to organize data in a table. Like your class schedule is organized in a table. I do everything in a table. My appointments, my meetings are all organized, just using tables. So I'm going to show you a way how to organize this data in a table, which is called the frequency distribution table. It's called the frequency distribution table. So let me walk you through the procedure of doing this, and you can stop me, guys, at any time if you have questions. Okay, and I would like your help as I do this. In order to organize the data in a table that's called the frequency distribution table, you need to pick the lowest and the largest value from the table. Can you guys see what's the lowest and what's the largest here?
Lowest is 31.
Do you see a 31?
On 33.
Oh,
33,
sure.
I mean.
Yeah. Yep.
And what's the largest?
50.
Yep. So that's the first step, guys, that you have to do. Next step, do the maximum minus the minimum. Which is 50 minus 33, which is 17. All right. Now let me tell you why we're doing this. To do a table, guys, you have to decide how many rows you're going to have in your table. Well, he's asking us construct a frequency distribution table with 6 classes. Let me tell you what a class means. A class means a row. He wants 6 rows in the table. Yeah. If I don't ask you how many rows I want on the table, I think one student can do the table in 2 rows, another one can do it in 3 and 4. But to be consistent, we want the table to have 6 rows. And look, I prepared 1, 2, 3, 4, 5, and 6. 6 rows of data. And let me continue and show you how we're going to proceed from there. So you do the minimum value, the maximum value, you subtract them, and then you do this. Divided by the number of classes. So 17, and he said 6. And what is 17 divided by 6, guys?
$2.83.
Yeah. Next thing I would like you to do, round up the answer. Not round it up to the next whole number. So what would 2.83 become?
3.
3. If we can agree on what I did, guys, and you understand what I did, this is the key to constructing the table. Once you figure this number here, I call it the magic number, we're going to be able to construct a table that contains all the data values in 6 rows. If he says 5 classes, you would have divided 17 by 5. And if you divide 17 by 5, you get 3.4. So that rounds up to 4. And if he says 4 classes, guys, you would divide 17 divided by 4. That will be like 4.25. And if you round it up, it will round up to 5. So, but in our case, it is 3. So let's continue from here. Okay. Here's how we construct the table. The first column has a heading. It's the amount of the bill. So we just call it amount here. Okay. Rather than, guys, listing single amounts here, I'm gonna list the amounts in groups, because if I list single amounts here, I would need more than 6 rows to display the data, because I have bills that are worth 33. I have bills that are worth 35, 38, 40, 50, 36. So you will have a table with probably 50 rows, just if you don't put the data in groups. So we're going to do groups here, which we call a class in a second. So here's how we start. You start with the minimum value. You put it right here. And you put 2, or you just put this hyphen right there. And look what you're going to do. This magic number 3, you add it vertically down. So a 33 plus 3 will give you what? 36. And then you add a 3 again. That will give you a 39. Then you'll add a 3 again this way. That will give you a 42. Then you will add a 3 again. You keep adding until you exhaust the 6 classes, the 6 rows. Okay. And the process I'm showing you guys, that you would do it for all frequency distribution table. The only thing will change is this value could be a different value when you do it. Okay. Can a student tell me what is the value that comes immediately before 36, which is a whole number?
35.
Yep. So that's going to be the 35 here. And any guesses how I'm going to come up with the numbers this way? What do you think I'll be doing?
Don't you do the same thing?
Yeah.
Add number.
Add a
Like,
3. 38. Add a 3. 41. I assure you guys, you're going to cover the entire data set. Look, the last value 50, and that's the maximum that we have. It's included already. Now, what does this mean? It means all values between 33 and 35, including 33 and 35. This all values between 36 and 38, including 36 and 38, and so on and so forth. We call them intervals, and we call them classes in statistics, and that's where these are your 6 classes. So if you ever see a table and he asks you what is the third class, you just tell the answer will be from 39 to 41. If he asks you what is the first class, you say it's 33 to 35. Your frequency distribution table, guys, actually has only 2 columns. I put 4 here, but we only need 2 for a frequency distribution table. The tally I just put there to help us count the values, but you only need the amount, and I'll tell you what the frequency means. The frequency means How many values are there in the data set that fall between 33 and 35 inclusive, and which we're going to find them right now? So between 33 and 35, guys, how many values do you see there? So I see 33 and 35. Here is one. Here is 31.
Professor,
Yes.
how's the first one up by 2 from 33 to 35 and the rest
No,
are
it's
up?
not by 2. It's actually, let's count them. 33, 34, and what? 35. It's the 3 values. And you don't count this way. I know what you did. You did the difference. You don't do it this way. You do the difference that way. Between 33 and 36 is a 3. Between 36 and 39 is a 3. So we don't do differences this way to match it with the 3. It's always matches this way, vertically. And the width of this interval actually is 3, as I counted to you. Count them, 33, 34, 35. It's a 3 values. Okay. How many values in the data set are there between 33 and 35? I think I counted 3 of them. That's how we tally them. Between 36 and 38, guys. Can you help me? We have a 38, 36, 36, that's a 3. And 38, that's a 4. And 36, that's a 5. And 37, that's a 6. And this is how we tally this. 4 and 1 and 5, that's a 6. Between 39 and 41, let's count them. 39 and 41, guys. 39, 41, 41, 40. Okay, how many do we have? Let me just get rid of the 36 and 38 as well. So we took care of that. Okay, so we said from 39 to 41, what do we have? We have 41 at the first row. And then 39, 2. And 3, 41. And 40 is 4. And 41 is 5. And 40 is 6. That's a 6 as well. That's how you tally that. 42 to 44, guys. Well, how many do we have? So let me just cross this off. Yeah. 42 to 44. And that 41 is done. 42 is 1, 43, 44, that's a 3, that's a 4, that's a 5, that's a 6. 45 to 47. What do we have here? 45 to 47, guys. 1, 2, 3. And then 48 to 50. 1, 2, 3, 4, 5, 6. And that takes care of the entire data set. Okay. Let me tell you what a frequency is, guys. A frequency is count how many values are there between 33 and 35. You already did it in the tally. Just copy the values from the tally sheet and put them as a frequency. That's a 3. That's a 6. That's a 6. That's a 6. That's a 3. And that's a 6. And if you just ignore this one for now, what you have is called a frequency distribution table with 6 classes. If I give you the same question on the test and I ask you to do 5 classes, all you have to do, guys, take the maximum minus the minimum divided by 5 instead. If it was like a 17 divided by 5, it was going to give you 3.2 or 3.4. Well, 3.4 round up to 4. So you come to 33 and add 4. And then add 4 and then add 4. But you end up with 1 less. You don't need, just 6 rows. In this case, it will be 5. Any questions about the frequency distribution table? Okay, let me tell you what a relative frequency distribution table. Let me see if I have any questions in the chat. Okay, good. Relative frequency. Relative frequency means those 3 will be what fraction out of the total? Well, if you count the total for me here, what would be the total of all frequencies? They call it sum of frequencies.
30.
30. And look how easy to find the relative frequency. Just do a 3 out of 30, a 6 out of 30, a 6 out of 30, a 6 out of 30, a 3 out of 30, and a 6 out of 30. And if you just divide the math, do the math. If he asks you to do a decimal places, you just do it. If not, you can even leave it as a fraction. Without doing the calculations, guys, what do you think the total should be here? Don't do the math. Can you get 1? Exactly, 100%. All the pieces will come together to 100%. And now you have, not only you have a frequency distribution table, you have what we call a relative frequency distribution table. So up to here, guys, you completed the frequency distribution table. If you add one more column and call it relative frequency, you have what we call a relative frequency distribution table. This one is called the first class. This is the second class, third class, fourth class, fifth, and sixth. Let me tell you what we call the first number in a class. This is called the lower class limit. And this number, guys, is called upper class limit. So there are times where I give the students the table and just ask him, what is the third class? So they tell me 39 to 41. Or I ask him, what is the lower class limit of the fourth class? You just go 1, 2, 3, 4. The fourth class is 42. And this is called the upper class limit. If you have a table, guys, and you are asked to find the class width, you don't do any of this work at all if you have the table already. All you need to do, guys, just take any 2 consecutive lower class limits and subtract them. 39 take away 36 is 3. 42 take away 39 is 3. You can do upper also. 44 minus 41 is 3. 47 minus 44 is 3, and so on and so forth. So I'm going to put a note here to find the class width given a frequency table. Simply subtract any 2 consecutive lower class limit or upper, but lower is the first one, so any 2 lower class limits, like these 2. For example, by mistake, students sometimes do it this way. And then they do 44 minus 42, and they tell me the answer is 2. Well, actually, if you count how many whole numbers are there between 42 and 44, guys, you're going to find out it's 3. 42, 43, 44. It's 3 values. Any questions? Okay, let's do some practice on this.
Can you leave that on there for like 1 more second?
Yeah.
I just have to take a little more notes.
You will, what I decided to do, and actually along with chapter 1 handout, I'm not going to wait until I finish this chapter. I'm going to send you the notes of whatever I get done today.
Okay, I'm good.
Okay, good. Number 2. A sample of 15 Boy Scouts was selected and their weights in pounds were recorded as follow. Using a class width of 10. He's telling us what the class width is, guys. He says it's 10. give the upper and lower limit for 5 classes, starting with the lower limit of 95. So he wants us, I started here, guys. If he doesn't tell me what to do, I start with the lowest value. But here he's telling me, no, I don't want you to start with the lowest. I want you to start with 95. So I have to start with 95. So how can we do a table that has a class width of 10 and starting with 95? So let's do it. I'm going to answer both questions in part B. So watch, guys. We'll put 95 here. Okay, can you help me out? What would be the next number? Going vertically down.
105.
105. Does everyone understand where she came up with the 105? Because we added 10, 115, 125, 135. Okay, who can help me figure out the rest? What would that be here?
104.
Yes, very good. It's the one immediately before 105 and add 10. All right. And now, guys, we can figure out how many are there between 95 and 104. Let's see, 95 and 104. I have 97, 100. Anything else? Yeah, 2. Between 105 and 114. Okay, inclusive. You can include 105 and 114, guys. So 108, 110, 106. That's the 3. Between 115 and 124. 1, 2, 3, 4, 5. Let me know if I missed anything. Between 125 and 134. 134, 126, and 3. Okay, that should be 2 for the last one. And yes, it is 2. There you go. That's a frequency distribution table, guys. Your table has 1, 2, 3, 4, 5 classes. 1, 2, 3, 4, 5 classes. And that's what we call a frequency distribution table. Okay. Okay, the next question is an easy one. He gives you the class, he gives you the frequency, and he wants the relative frequency. Construct a relative, so just add one more column and call it relative frequency. Can you guys help me? How do I construct this column? What do I do? Just like we did in the first one. Just let me have you observe what we did in the first one.
You add all the frequencies together.
Yeah, you add up the frequencies and divide them. Exactly. Sum of the frequencies, if you add them, guys, it will be 49. So that's 5 over 49, 8 over 49. Now in my math lab, he might ask you, he wants the answer rounded to a 1 decimal place or 2 decimal places. Just follow directions, guys. If he says leave your answer as a fraction, you just leave it. But let's say he says I want 1 decimal place, you just divide 5 by 49 and try to get the answer. So 5 divided by 49, for example, guys. He might say 2 decimal places, it will be 0.10, and so on and so forth. Okay. Now we're going to learn how to construct histograms. So if you are given a frequency distribution table, you can make another display. It's called a histogram, and I'm going to explain what the histogram is. There is a frequency histogram and relative frequency histogram. So I'm sure, guys, if you had some knowledge of beginning algebra, you know what this one is: the x-axis, this is the y-axis, this is the origin right here. This is a horizontal line and a vertical line. My horizontal line will be always the classes, so it's going to be the weight. My vertical line is going to be always the frequency. Okay. I want you guys to suggest a scaling for me. We need to scale only the frequency line. Don't worry about the horizontal line, the frequency. I know the highest is 15. I'm not gonna do 1, 2, 3, 4, 5, 6. It's just gonna take time. So what do you suggest? How would we scale this up to 15?
4
by 4 each time we can do that. So that will be a 4. And then the next one will be what? 8. And then the next one will be what? 12. And then 16. I think we got enough. You could do 3, 6, 9, 12, 15. You can do 2, 4, 6, but 1, 2, 3, it's just going to be very busy, very crowded there. So that would work. And let me show you how we construct a histogram. A histogram, guys, is a bar graph with bars, columns, but they connect. There are no gaps between the bars. They touch each other, and that's how I'm going to try to construct this and show you how to do the histogram. So for the first class, the frequency is 6. So I need a 6. 6, guys, will be halfway between 4 and 8, so it should be somewhere here. And I can start anywhere I want. So I'm going to start my histogram right here. That's the first bar. Okay, the next one. I need a 4. And remember, the bars must be connected. It has to be the same width because they all have the same class width, guys. Remember that. So a 4 will be right here. Okay. Then 11. 11, I have to go a little bit lower than 12. Same size. Try to be consistent. Then 15. 15, I have to go a little bit lower than 16. Almost at 16. And then 8, there you go. Okay. Now we need to label the bars. I'm not going to label them and write 135 to 139. That's just going to make it a little bit ugly here and not easy to read. So look what we're going to do, guys. We're going to be creative here. Rather than writing from to, I'm going to pin the middle value right here and ask you to suggest some numbers for me. What number would go there? Right in the middle. Just look at the class here.
135.
135 is the beginning. This is
137.
137. And do you guys know how he came up with 137? It just added the 2 and divided by 2. This is the middle, halfway through. So you do 135 plus 139 and then divide by 2. 130. Okay, what would be the next number, guys? Do you agree with me? It's 142. And this is 147. And this is 152. And this is 157. And probably you're wondering, how did I know that? Well, I'm not doing the math here. What's the class width? Can you tell me, guys, what the class width is here? Just going this way.
5.
5. You just add 5 every time. Look what I did. 137 plus 5, 142 plus 5, 147 plus 5. That's the beauty of the class width. So you don't need to add these two and divide by 2, add these two. Just once you get one, you pick up the rest using the class width. All right, let's see. Now, this is supposed to be 0 right here. I didn't start, I started, just move to the right and then start. You have to show this. If you're doing, honest statistics, you tell the reader that I did not start at 0 and you just do this break in the line. I think you've seen it in graphs. So this simple means that I did not start at 0. I just started anywhere I wanted. And now, guys, you have what we call a frequency histogram. This is the frequency histogram. The bars are connected, as you can see. But I'd like you to look at something here. Well, actually, the table doesn't reflect on the bars. I don't think, according to the table, they should be connected. Look where the table says 135 to 139, and then there is a gap, and we jump to 140. So there is a gap from 139 to 140, which of 1. What's the difference between 139 and 140? It is 1, but it didn't show that there was a gap here. So this is the job of the software, guys, when you create a histogram. Like if you ever seen Excel or if you used Excel, Excel can do histograms for us. You just enter this data here and Excel will figure it out. But Excel, while you try to do a histogram, is gonna ask one question. Would you like gaps or no gaps? If you tell Excel no gaps, because you should, this is how a histogram is done. Let me tell you what Excel does. Excel, it will find the difference between the end of the first class and the beginning of the second one. If it finds it's not 0, then there is a gap. It will compute this gap, which is a 1. And look what Excel does. It will take the 1 and divide it into 2 pieces, a half. It will subtract a half from the lower class limit and add a half to the upper class limit. If you take it from the lower side, guys, and you give to the larger side, the other side, it's just like you did nothing. So it's just you didn't make any changes. So look what happens with Excel. And this is something you don't have to worry about. It's all done in the background. Excel will deduct a half from this. So that will become 134.5, and it will give that half to the 139. And then it will deduct, that will be 139.5, and that will be 144.5. And then 144.5, and then 149.5. Did you notice, guys, that the gap has disappeared now? You're going 139.5, starting at 139.5 for the next bar. Ending at 144.5, starting at 144.5. This is what the histogram, just represent. Not exactly that. And this is the software, just take care of all of this. The next one, guys, would have been 149.5, and then 154.5, and then one more.
I had to get up and I missed it when you went over class width. So how did you find that?
Oh, there's just the gap between 139 and 140. What's the gap between 139 and 40? It's 1, correct?
Correct.
And what Excel does in order to compensate, just for the gap, we have a gap of 1, but you didn't see any gap here. It's a 0 gap. They're connected. What Excel does, it takes that 1, divided into 2 pieces, so it will be a half. It will deduct a half from the lower class limits and add a half to the upper class limits. So subtract a half, add a half is just like you change nothing, but just to make the graph look like the bars are connected. That's the only reason for that. This number here, guys, is called the lower class limit. This number right there is called the upper class limit. Now, what do we call those numbers when we subtract a half and add a half? We call them lower class boundary and upper class boundary. So we use the word boundary when we construct histograms. Nothing changes at all. It's just a matter of how the software, just does the graph. What I would like you to do, guys, look at number 5. Take a few seconds and tell me which one is the correct answer. Oh, the bar graph, just for your information. A bar graph is just like the histograms, but the bars are not connected. So the bars would look something like this. That's what the bar graph looks like. So tell me, what do you think the difference between a bar chart and a histogram? Which answer would you select? A, B, C, or D?
Is it B?
C.
Okay, let's see why it's not B. The bars in the bar chart may have various widths.
I
No,
think it's C.
all the bars have to have the same width. Probably I wasn't 100% consistent, but the class width is the same. They should have the same width. It is C indeed. The bars on the bar chart do not touch, while the bars on a histogram do touch. Exactly, that's the case. But they do represent very much the same thing. We're interested in histograms and statistics, not in bar graphs.
Professor,
Mm-hmm.
how many questions will we get like this on the test?
What do you mean by? I
Like,
could give you a table and ask you several questions on it. It could be more than one question.
Oh, okay.
So you could have a lot of questions. Like I could ask you, how many classes are there? You count them, 1, 2, 3, 4, 5. I could ask you, what is the third class? 145 to 149. I could ask you, what's the class width? Distance from
So-
135 to 140, and so on and so forth.
Professor, so are they going to be similar to these kind of questions?
Yeah.
Okay.
Yeah, you're not gonna learn anything in here and just see something else later. It's very much reflects on what you're learning.
How many questions are there in the test, like on average?
Well, that's something I don't want to discuss now. I don't know yet. So we'll talk about it next week.
Okay.
Construct a frequency polygon. Let me tell you what a polygon. Polygon means, poly means many, and gon means lines. So how can we sketch data, just using a polygon graph? I'm just going to show you this, and that would be the end of section 2.1. But before we do that, guys, we will construct a histogram, because a histogram will help me show you what a polygon would look like. So you guys have already the data, and you have the frequency table. But before I get to that, I just forgot to mention, he says here, construct a frequency histogram and construct a relative frequency histogram. There is one thing I can change here, guys, and it will become a relative frequency histogram. Just one thing. Can you tell me what would that be?
The scale.
Okay, how would you change the scale?
I would make it reflect the relative frequencies.
Okay, you just divide by the, what was it here? What was the total right here? Whatever the total was, guys, you just divide, just by the total.
It's
you get-
44, I think.
Yeah, just divide by 44, divide by 44, divide by 44, divide by 44, and then your histogram will become a relative frequency histogram. So just construct a frequency histogram and just divide those scales, you know, by the total number of values that you have, and it will become a relative frequency histogram. All right, let's see here, guys. Okay, let's construct this. I need to scale it. I need to go as high as 13, guys. So I'm gonna do a 2, a 4, a 6, an 8, a 10, a 12, a 14, and that's the frequency. And that's the height here. And in inches, okay, and that's a 2, a 4, a 6, an 8, a 10, 12, and a 14. You're ready to see? Let's do a histogram first. So that will be an opportunity to just demonstrate histograms one more time. So we need 5 for the first one, guys. So 5. It will be halfway between 4 and 6. So I'm gonna just start here. And then 8. Just go up to 8. Then 12. Just gonna go higher to 12. Then 13, a little bit higher. And then 11. 11 is halfway between 10 and 12, guys. So it will be somewhere here. All right. All right. That's okay. I need midpoints here. Can you help me out with this? What would I put there?
51.
51. And look, guys, don't look anymore. Just figure out the class width, which is from 50 to 53 is a +3. Just add a 3. 54, 57, 60, and 63. Look how easy it is now. Okay, let me show you how to construct a polygon graph. Let's use red in here. Okay. You mark the beginning of the first bar right here with an X. And you mark the end of the last bar with an X. That's the first thing that you have to do. Then you go to the top of each bar and you mark the center of the top, which is right here, right here, right here, right there, and right here. And from the first X, guys, you draw a line that connects the first point. From the second point to the third. From the third to the fourth. From the fourth to the fifth. From the fifth to the sixth. And from the last one, just make sure it's going to be this line right here. And this is what we call a frequency polygon. So once you do a histogram, you can easily do a frequency polygon. Mark the beginning of the first bar, mark the beginning of the end of the last bar. Put dots at the top of the center of each bar and just connect them with lines. You're going to get 1, 2, 3, 4, 5, 6 lines here. With 5 rows, you get 6 lines always. Okay. Any questions here about the frequency polygon? So this is what we call a frequency polygon. All right. And that concludes section 2.1. We're done. Section 2.2, guys, which is stem and leaf plot. That's a very easy section. It just takes a few minutes to complete.
Professor, I have a question.
Yes.
At the beginning of the lesson.
Stem and leaf, guys. It is what it says. You split up the data into two pieces. One is a stem and one is a leaf. For example, guys, he's given us utility bills in 2 digits. You know, the first digit is the ones and the second one is the tens. So here's how you can do the stem and leaf. You just write a stem here. You don't have to write it, but just since it's the first time I'm doing this, so I'm just gonna do a stem and leaf like this. 44 has 4 tens and 4 ones. 38 has 3 tens and 8 ones. Then 4 tens, 5 tens, 3 tens, 3 tens. So it seems to me I only have 4 tens, 3 tens, and 5 tens. And here's what I'm gonna do. I'm just gonna put a 3, a 4, and a 5. These represent the tens. Your leaves, guys, or leaf is gonna represent the ones. And here's how we list them. Watch. We go to all numbers that have 3 tens, which is the 38. Since I already recorded the number of tens, I just need to record the number of ones, which is 8. Then the 6. Then the 6. Anything else here? Then the 5. Then the 7. Then the 9. Then the 8. 6. 5. And 3. That's for the 3s. 4. Let's do the 4s. 4. 1. Just correct me if I make a mistake. 3, 2, 9, 8. I'm making them closer to each other because I need to have enough space here. Then 0, 1, 3. Then 5 and 5. Then 1, 7, 0. Then 2, 3, 8. Wow, mostly. And then for the 5s, guys, I have 0, 0, 0. Okay. This is what we call a stem and leaf plot. But if someone doesn't know any statistics and have no idea how you constructed, just this graph, you have to give him a hint. What kind of hint would you give that person? So they know how to read the graph and understand it. What would you do? We're gonna call the hint a key. You need to provide a key for people to unlock this graph and understand it. What would be the key?
Maybe I'd put like a number 10 with a line through it
Yeah.
and just put equals 10.
Well, actually, it's better to use something that you already have in your data. 3, 8 means you need to tell the reader what do you mean by 3/8, guys. It means 38. And then a reader would understand that 3/6 means 36. 3 vertical line 5 means 35. And that's the key. That's very, very important. I do always ask, just for that key, if I ask you to do a stem and leaf plot, that's very important to include the key. So this is what we call a stem and leaf plot. Based on the stem and leaf plot, guys, forget about the raw data set. What would be the most common amount, just as far as utility bills?
4.
In the 40s. You can say it's in the 40s. And the least amount, it seems like the 50. See, there is only 3 of them. And actually, guys, for your information, if I try to turn this, rotate this page this way, let's see what happens. It will turn into what? A histogram. So it looks very much like a histogram. All right. Let me give you another example of a stem and leaf plot where we have more than two single digits. Construct a stem and leaf. Let's put some numbers. Okay, that's enough. Can you help me, guys, with the stem and leaf now? What would go in the stem and what would go in the leaf? How many digits should go in the stem? The leaf should always be a single digit. So what's left for the stem? 2 digits, right? The tens and the hundreds. But don't repeat them, just whatever shows up. So we got 1, 1, 1, 1, 1, 2, 1, 0. You start with 1, 0, 1, 1, and 1, 2. Okay, I got 103. That's the first one. I got 5. I got 8. I got 3. And I got 0. Let's go to 1, 1. I got a 0. I got a 7. I got a 1. I got a 7. A 5. Last one, 12. I got the 1, 2, 1. And I got 0. I got the 3. And I got the 1. And we need a key, guys. Don't forget the key. Just tell the reader that 1, 0, vertical lines 3, read it as 103. And that should complete your stem and leaf plot. I would like to bring your attention to misleading graphs. Somebody is making a claim, guys, that their volume of sales have doubled. So what they did to show this, they represent their sales from before as a 2 by 2, and then they represent their sales now as a 4 by 4 because this has doubled. So they put 2, they make it a 4, the 2, I make it a 4. Does this give you an impression here that the volume has doubled of sales? What kind of impression will you make when you see something like that?
Probably that it's quadrupled.
Quadrupled. It's not doubled. But they're misleading you and trying to give you an impression, just that it's not, just a correct impression. So what is so the mistake that they make, you had 4 units. You had 4 units, guys, and now you end up with 16. That's not correct. This is a misleading statistics. So what did the person do here? Actually, let's see. The length of the side has doubled, but the area has been multiplied, just by 4, and that's wrong. It should be multiplied by 2. If he says double, just make it double. Don't make it, 4 times as big. So that's a wrong impression. This is an example of misleading statistics. Let me give you another example of misleading graphs. And there are so many of them, guys, that you should start being aware of after you learn statistics. This graph is misleading. Can you guys tell me why, if you've seen graphs before?
The vertical axis starts at 10,000.
Yeah, usually the vertical axis, if you learn beginning algebra, guys, what is this point here called?
The origin,
And what does it have?
0, 0.
Yeah, it is not 0, 0, it's 10,000 here. That's misleading. And just give me a chance to show you how I can even mislead you, not just with this, when I do something like that. So just one sec. If I'm good with statistics, and I work, just at this as a salesperson, I want to impress my boss, my superior, and I show him this graph. I said, look at my sales in 2020 and look at my sales in 2021. What do you think the impression that my manager is going to make right away? What impression would my manager make?
Your sales doubled.
My sales doubled. And why does he make this impression? Because I tricked him. I didn't start at 0. So I said, I want to start at 50,000, and then I scaled 4,000 each. But look, my sales guys went only up from 54,000 to what? 58,000. How much up did they go? 4,000. Do you guys agree that they didn't go double? They didn't go double. That even shows that if you know how to criticize, just the labeling that I did. You cannot get me in trouble for doing this, but I can try to cheat, the ones who's not gonna look, just at the numbers there. The ones who are not gonna look there, they're gonna walk out with a totally different impression, and probably that's what I want. But you wanna see the real graph, guys? If you wanna see a true non-misleading, this is misleading. I think you should agree that it is misleading because it gives the impression that the sales have doubled, but they didn't. Let me show you how a true one would look like. Just give me a second. What do you think, guys, now? Is this acceptable, the second graph? Does it reflect, just very much, just the real case? It does. You can see 54 to 58, a little bit higher. That's it. That's how it should show it. But if you want to play with the graphs, guys, you can use this one, mislead people. You can do it. If people are smart enough, they're going to just look here and they say, well, he's trying to mislead us. And look, this is a 50,000. But if they don't notice it, they get fooled. A class width, guys, it's upper value minus lower value divided by number of classes. Round up the answer. What is a lower class limit? Lowest value in the class. Largest value in the class.
Mr. Bagby, I have a question.
Yes.
Let's say, for example, you get the class width and it's already a whole number. It's not a decimal.
Yeah, you just leave it. Yeah, that's a good question. You leave it as is. If it works and it covers all the data values, then you're good. If it doesn't, just up it by 1. But you just try it out first of all if it works.
Okay.
Yeah. Good question. Class.
Number of rows.
Yeah, it's just a range of values. It's just each class. Yeah. It's a range of values. Frequency, how often a value occurs in a class. So just get used to the word class, guys. It's just an interval. Histograms, bar graph where bars are connected. They call them columns as well. Relative frequency, it's a frequency divided by the total. Stem and leaf plot, a graph with stem and leaf side by side. Okay, I guess that's it for what we have done. So section 2.3, it's called the measures of the center. In statistics, people are interested to know what happens at the center of the data on average, what's going on. Like I put this example in there. A graduate teaching assistant students in math was asked to grade 40 final exams, selected at random from several large sections of an introductory course. Then these are the resulting scores are found below. Well, these are the results, but if the professor, just who teaches the course, want to look at the results, I don't think it wanna be easy for him or her to figure out what's going on average for the class if he doesn't have, just some simplified, just measures. It will be hard to tell. I mean, one student's got 77, another one got 68, 86. How is the class performing, just as a whole? It's very difficult, just to be able to tell if you don't summarize this data. Imagine there, guys, when you only have 40 values, imagine that you have a full page of values, like 700-800 values, and you are asked to say something about the data. You won't be able to unless if you summarize it. And you're gonna learn how to summarize your data using measures of center. I think you're aware already of all of them. There are 3 measures of center, and they are all called averages. One is called the mean. That's the one that you know of as the average. Another one is called the median. It's the value in the middle of the data set. And the third one, which is not very important to us, it's called the mode. The mode is the value that occurs most often. So I'm just going to show you how to compute all those 3. So the professor for the class asked her how the students performed. Unfortunately, the graduate students found that looking at the list that scores was about as informative as looking at a scrambled set of letters. It is true, guys. I don't think you have an idea already how the class, just performed on average. So to get the information out of the data, she needed to summarize the data. And so how should she go about summarizing the scores on the test? The reason why I put this introduction here just to give a segue, just to what we're going to be doing today and just why we need to learn measures of center or central tendency. The first measure of central tendency or measure of center is called the mean. And how do you compute the mean, guys? The mean is the sum of all the observations divided by the number of observations. That's how you find the average. It's called, most of us who don't use statistics, they call it average, but in statistics, it's called mean. If your data, guys, comes from a sample, your mean is called X bar. So if you have a sample data, the mean is called X bar. We write it like this, X bar. If your data comes from, if your data is the population, which is unlikely, the mean has a different symbol. It's called the mu. We write it like this. It's a Greek letter, okay? And I'm going to show you as a first example how to compute the mean. I'm going to show you how to do it by hand, and then we're going to use technology. You're going to see the power of TI-84 starting today. The following are salaries for 4 randomly selected employees at Microsoft. First of all, guys, can you tell me, does this data represent a sample or a population?
A sample?
Definitely, because Microsoft has more than 4 employees. If Microsoft has only 4 employees, that would have been the population, but it is more than 4 employees. So how do you find the mean? We call it X bar. We add the values. And what do we divide by? What number, guys?
4.
Yep. Just divide like this. Okay, let's see what the answer is. $130,000. I'm just gonna use the calculator just to add in, but that's not how we're gonna find the mean. You're gonna see a better way, guys, more effective way of finding the mean. Especially when you have too many values, you're not gonna add them just like this. So I add them and then I divide by 4. I got 133, $625. That's the mean. How do you find the mean using your calculator? You're ready for this? I already have a video in place. It's only 3 or 4 minutes, just dedicated to show you how to find those measures of center using your calculator. I will make this available. But let me just show you. As I told you, I will assume that you have no knowledge whatsoever with the calculator, and we're gonna start from scratch. First of all, the calculator, in order to do this for you guys, you need to input the data. And how do you input the data into a calculator? Here's how you do it. No other ways. The only way, you go to Stat, and you hit Edit, Enter, and let me just clear this one. You're gonna see your calculator looking like this now. You start typing in the values from the data that we have. So we have 130,000. You just go to 130,000 and press enter right here, guys. And then enter the next value, which is 135. And enter the next one, 133,500. And then enter the last one, which is 133,000. If you have 50 values, you can put them all in here. That's the beauty. You don't have to do the math and add them one by one just to find the mean. And now look what you do, guys. Now the step to find the mean. You click on Stat again. So in chapter 2, everything is gonna be here, right here, Stat. You don't do edit, you already did the editing. So you just do the next one. To move to calc, guys, it's the right arrow key will move you to calc. You press enter and you just scroll down and hit calculate. That's all you have to do. Oh, I made a mistake actually in the data entry. 130,000, 135,000. Oh, this should have been 136 here because they have to match. Whatever I did by hand, guys, has to match. So let me just go back, Stat, Calc, one variable statistics, and calculate and watch. There you go. Perfect match with what we did by hand. All right, where is the mean? It's the first value. That's the mean. Don't worry about the rest. We'll come to it, just in a little bit, but just you need to know that the first value is your mean. That's how you use the calculator. Median. The median for a set of observations is defined to be the middle value. When we put the observations in order from smallest to largest, you just find the middle. And we're gonna find the median of this data set right here. So let's do that. Okay. First of all, guys, you have to rank the data from smallest to largest. So just put the smallest value. Next one is 133,500. And then 135. And 136,000. Okay, where would be the middle of this data set, guys? Let's see. Here's how I tell students to find the middle. I said cross one off from right, left. One from the right, one from the left. Oh, here is your median right here. What would be a compromise, guys? We need a median. It landed in blank area. What would you value the blank area here?
Can't you add those two up and then divide them?
Yep. That's the only choice that we have. And then there will be 134, 250. That's how you find the median. For your information, guys, your calculator has computed the median already. Okay, you see where this arrow says it point down, down. So this is the down arrow right here. I'm just gonna click down and show you where the median is. Here you go, MED, 134, 250. If you wanna know what min means, the smallest value. And there is a max, guys, if I just scroll down, which is the largest value.
Professor,
Yes.
on my calculator, when I click stat and I click on edit, you see how your calculator says L1, L2, L3, L4? Mine is just blank. And then every time I try to input a number, it tells me error.
Oh, really?
Yeah.
If you want, I can look at it later. We can reset the calculator, no problem. I'll send you some directions to reset it and then try again.
Okay.
Well, who's this?
Hussein.
Hussein, right? What's your last name, Hussein?
Al-Shibil.
Okay, I'll send you an email shortly.
Okay.
No problem. All right, let's see some more about the median, guys. Just want you to experiment a little bit about the median. Let's say we have odd number of values. One, two, three, 4, 5, 6, 7, 8, 20. What would be the median? If you have an odd number of values, the good news is the median is going to be one of those values. And you can see, guys.
7.
Yeah, if you cross off, well, we're not going to do this cross off game because it does take time. There you go. Here's a question that I asked students on the test, probably not last semester. I said you have 89 values. Where would the median be located, in what position? Before you answer this question, guys, let's give you a hint. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. My median is in the 5th position. Watch, 1st, 2nd, 3rd, 4th, 5th. You can count this way. 1, 2, 3, 4, 5th. And if you go back to the previous example, I have 4 values. My median was located between the 2nd and the 3rd. 1st, 2nd, 3rd, between the 2nd and the 3rd. So if you have 4 values, it's between 2nd and 3rd. If you have a 9 value, it was the 5th position. If you have 89 values, guys, where would the median be?
The 45th position?
Yeah, the 45th.
Very good. And how did you know that?
I just divided 80 in half. That would be 40. And then I added the 5 because out of 89.
Oh, okay. I'm going to make it simpler. If you have an odd number, guys, add 1 to it. So what's 89 plus 1? 90. Divide 90 by 2, you get the position. It's all written in the handouts and how to figure this out. So let's now do an even number of values. If you have 46 values, guys, where do you think your median would be?
Between 23 and 24.
Excellent. So look what you do. Take 46 and divide it by 2, just like 4. Take 4 divided by 2, you get 2. It's between 2nd and 3rd. Take 46 divided by 2 will be between 23rd and 24th position. And guys, actually, this information is right here. Already provided this information. We're gonna do the mode now of a data set. The mode is a value that occurs most frequently in a data set. So if you see a value that repeats more often than more than the other values, then that would be your mode. You could have more than one mode, and if you don't see any values that are repeated, then we can say that there is no mode. Can you tell me what would be the mode for this example? What value do you think repeats most often?
84.
Yep, because it repeats 3 times. This morning, a student told me that, what about 86 or 82, Mr. Bazzi? Well, I said 86 repeats only 2 times. You cannot count it because 84 prevails. It repeats 3 times. So mode is 84. All right. What type of data, guys, that you learned yesterday and before yesterday? It's not possible to find a mean and median for it, but you only can find a mode. Can you fill in the blank here?
Qualitative?
Qualitative data. Because it doesn't have numbers to add and subtract. But for qualitative data, guys, you can find the mode. For example, if I ask you guys, what's your favorite color? And then you write your favorite color. If I see like 10 students favored the color black, then I tell you the mode is black because most of you favored, just black. That was the prevailing one. But I couldn't find the mean of the colors or the median of the colors. That can't work. It's not a number. All right. What do you think? Right here, it's going to be the mean or median is often preferred. Mode, we don't like the mode because the mode could be toward the end of the data set, represent a large value, small value, but not the center of the data. It could be anywhere. So for what type of data we should compute the mean or the median?
Ordinal?
Not ordinal. What's the opposite of qualitative?
Qualitative.
Quantitative. Actually, for ordinal or nominal, it's going to be qualitative most of the time. So it's only interval and ratio, mainly ratio, guys. All right, for the last two, guys, let me just give you an example before I go back and fill in the blanks. This example showed up on the final exam in one of the semesters, so just pay attention to it. It's very, very important. And let me tell you, I'll tell you what is it going to be about in a second. It's one of my favorite examples to teach students when you should use the mean and when you should use the median as a measure of center, because you guys learned that there are 3 measures of center. Now the question is, which one do I pick and tell people that this is the best representative of the data set? All of them, one of them, 2 of them? You're going to learn that in a second. Let's say, guys, we have a portion of a street, a street block that has 6 homes. With the following estimated values: $100,000 one home, another one is 98,000, one is 104,000, one is 94,000, one is 95,000. And this home happened to be, guys, built on a triple lot. It cost $960,000. All right. We're going to do two things, guys. First of all, I like it to find the mean and the median. And you know what, guys? Let's do it on the calculator just to demonstrate the use of the calculator one more time. So look what we're going to do. By the way, the student, well, let me show that. If you have issues with your calculator and I'm not around and you need a quick fix, this is what I would do. I would just reset it. So to reset the calculator, you just press the second key and you go to plus key and reset. Enter. Defaults. Now it's confirming. Do you really want to reset? Yes. And now it's back to how it was, you know, just when you first got it. And now I'm going to go to stat, edit. Okay. We're gonna.
Professor,
Mhm.
I did that and the thing still doesn't show up, the number, like the L1 that you have on the top.
But you have other than L1, right?
No, I don't.
Okay. Do
They were
this.
there, but I accidentally moved them.
Oh, okay. Look what you can do. Okay, let's fix this here. Show other students. Click on stat.
Yeah.
And then go to number 5.
Setup editor. Okay.
Yeah. Press enter twice. And try again.
Okay. Now click stat, edit. Yep, they're there.
See?
Okay. Okay. Thank you.
I'm very good at using this calculator. I know all the pretty much the issues. So usually I can troubleshoot, you know, just those issues. All right, so let's enter the values. Stat, edit. So if you guys ever lose L1 or L2 and you want him back, just do what I suggested to the student now. Okay, 100,000, let's begin. Watch, guys, 98,000. Some students might prefer to do this by hand, it's faster, but if you're good with typing, that will be fast as well. 94,000. 95,000. All right, you're ready, guys. So we do stat, calc, one variable statistic, and you don't do nothing here. Just go to calculate. Just go to calculate. Watch. Okay, the mean is $247,833. And let's see what the median is. Let me write it down first. X bar, which is mean, 247,833. And median is, here's how you find it, just 97,000. There's a big difference. Okay, let me tell you what we're gonna do. You live in this house, guys. That's your home. And I'm a realtor, and you hire me, you know, just to sell your house. I can make this promotion for this house. I can say, and put it in writing, we're offering a house for a bargain with less than $100,000, whereas the average price of a house in this neighborhood is $247,800. Can I do that? So I say, we have a bargain here. come and buy this house for less than $100,000, $96,000. And just for your information, the average price of a house in this neighborhood is about 250,000. I can bet you guys, you're gonna have, just people calling, just want to see this house because you're telling people that you're getting a bargain for 100,000, whereas the average price is 250,000 or $248,000. I would say probably it's not ethical to do that, but you can do it and nobody can get you in trouble for doing this. Why it is wrong, just to use the mean to advertise, just the value of the house? Why do you think, guys, that it was wrong of me to promote the house using the mean?
Because it takes into consideration like really expensive homes as well. So it's probably not going to
Oh, no,
be.
I'm not saying, but one thing, guys, before I stop, I didn't mean to consider this house. This is 960. I wanted to do the other one. We're not selling this. I thought it was 96,000. So just let me repeat back. We want to sell this house. I just noticed that I put 900, it's a 960,000. So we want to sell this house. We tell people, come and get a bargain for 95,000, and the average price of a house in this neighborhood is 250,000. And this is wrong, guys. Realtors should not be doing that. And actually, many of them don't do that because that's very misleading to people. Why it is wrong to use the mean when you advertise, promote the value of a house? Why in this case it is wrong to do it?
Because there's different like classes of house. You have luxury homes and then you have your middle level.
So you guys agree with me that the luxury home price impacted, just the average value of all the homes? It inflated it big time. It did. When you have an extreme value in a data set, guys, the value that you don't think it belongs there. And actually, guys, I don't think the 960,000 belong to this neighborhood. This is the neighborhood. That's what reflects on it. That's a stranger here. Doesn't belong there. When you see a value that doesn't belong there, you should not even think of the mean as an average. You should use only the median. If the realtor was honest, he could say, the average price of a home in this neighborhood is $97,000. You're getting a house for about $95,000, which is very much the median. That is the real deal. And that's the proper way, just to promote the value of the house or promote the house. So in the presence, guys, of extreme values, refrain from using the mean and use the median instead. And this extreme value is called outlier. It is called an outlier. All right. So I'm going to go back here, and now you can help me fill in the blanks. If there are outliers in the data, which one is preferred, the mean or the median?
Median.
Median. And you understand why now? Median is preferred over the mean, as the mean can be misleading when outliers are present. If there are no outliers, guys, your best bet is the mean. It's the best average. Just use the mean. Is often the preferred choice because it has some nice properties, which will be important in making inferences later in this course. So we need to understand the mean. It's very important. Okay, a couple more things before we wrap this up. You guys, when I compute your grade, I use what we call the weighted mean and weighted average. I will not be asking you questions, just on weighted mean, but I would like to explain to you, just how your grade is calculated. So it's good to understand just weighted mean for the sake, just of your grade. So suppose your grade is based on the following, and your exam one is 20% of your grade, Exam 2 is 20% of your grade. Final exam counts 25%. Just like in my syllabus, I gave you so many different percents. Your homework, like in my class, is 12%. Here we put it 20%, and your project is 15%. How do I go about computing your grade? Actually, there is no 15 per lab here. And the homework is 20% here, and the project is 15%. Okay, let me show you how I compute the grade. I see what you got on exam 1. You got 84. I multiply by 20%. So I just do 0.2 times 84, which is 16.8. Then I go to exam 2. You got 75. I take 20% of it times 75, which is 15. Then I go to your final exam. You got 72. I take 25%. So I multiply 125 times 72. You can use your calculator, guys. That will be 16. Then your homework, you got a perfect score. I give you 20% of 100, which is 20. And then finally, you get 15% on the projects, 15% times 85, which is 12.75. And what do I do with all those numbers, guys, to find your final score?
Add them up.
Add them up. Nothing else to do but this. And that would be what, guys? 31, 41, 47, 67. It's going to be over 81, so it's going to be just a B grade. Over 80%. And that's how, I don't do that manually, guys. I just have the grade book in my math lab or in Excel, just do that automatically. Just for your information. And the end of section 3 of chapter 2, you learned about histograms. Histograms have different shapes, and there are some 4 specific shapes that I would like you to be aware of and try to understand them. And there is a shape, guys, that it is so common. Any data that we collect, most data that we collect, and try to put it in a histogram, graph it as a histogram, will turn out to be like this. This shape is called a symmetric histogram. Why we call it a symmetric? Because it looks like, pretty much a symmetric. If you think of this as a mirror, whatever you see on the right, it's going to reflect, just on the left. This is called a symmetric histogram or a symmetric distribution. If I ask you what is the mode of this distribution, the mode will be the tallest bar. And the tallest bar, guys, it's right here. And what's the value under the tallest bar? You can see it's between 7 and 9. It's 8. The nice thing about symmetric graphs that the mean and the median and the mode are exactly the same. So if I give you a symmetric curve, guys, and I ask you what's the mean and median and mode, you just look for the value right here in the center. So it's 8. The mean is 8, the median is 8, and the mode is 8. And it has a different name that you're going to learn later next week. It's called bell-shaped, actually. The symmetric graph look like a bell-shaped curve. And let me show you why we say bell-shaped. Watch. If I connect the tops of the bars, it looks like a bell-shaped graph. How was this created, guys? You have the data. You can ask a software program. I'll show you later, just next week, and how to use StatCrunch to do a histogram, and it will do it for you just like that. So that's one shape. Here is another shape we're not very interested in. All the bars have the same height, as you can see, guys. All have the height of 20. So we don't have a mode here because everything is repeated 20 times. So there is no mode. And look, 1 is repeated 20 times, 2 is repeated 20 times, 3 is repeated 20 times. This graph is called uniform, consistency all over the place. And I'm going to give you an example of a uniform experiment. If I roll a die, guys, 600 times, how many times do you think I should expect to get a 1 face up, a 2 face up, a 3 face up, a 4 face up, a 5 face up, 6 face up?
The same
100.
amount of time.
Same amount of time. If you don't have a loaded die, if you have a fair die, then yes, same amount of time. Let me demonstrate this to you guys. I'd like you to see it. Watch. On the calculator, there is a program that it's gonna show you this. Okay. I'm gonna clear. I'm gonna go to the apps. Okay, we're gonna roll a dice. And we're gonna start rolling. Okay, I got a 6. I'm gonna do this, guys, 600 times, as I promise you. And I promise you, you should get something close to 100. It's not gonna be a perfect 100. It won't be, but it should be very consistent. Let's see. So let's start with 50. Another 50. Another 50. Another 50. Another 50. This is a computer simulation. Instead of me doing it by hand, I could do that by hand, but it will take me the class time to do it. Here you go, guys. It looks uniform. It's not going to be perfectly uniform, but it does look very much, just of a uniform. A student asked me earlier, do we call it uniform? I say, yeah, you can, or you can say approximately uniform, but it should be uniform. Look, 96, 100. I got here a little bit more, 91, 105, 98, very close to 100, guys. And that proves that this is a uniform distribution. Okay, let me show you the next two. That would be it. This is a histogram, guys, but you notice that there is a tail toward the left. See, there is a tail toward the left. This is called the skewed left distribution. The mode will be the value under the highest bar. So the mode is right here. See, this is the highest bar. The mode will be right here. But let me show you how to tell which is the median and which is the mean when you have a skewed left distribution. Just take this information and keep it in mind. The mean is always the closest to the tail of the distribution. So if I put two values right here, guys, and I tell you one of them is the median and one of them is the mean. As I told you, the mean is the closest to the tail. So then that must be the mean because that's closer to the tail of the distribution, and that will be the median. And this is called the left skewed distribution. Let's go to this one. That's called the right skewed distribution. And watch, it's like this. Okay, the mode is always the value under the tallest bar. But if I put two values here, for example, he says the mean and median right there. If I give you this curve, guys, and I put two values and I tell you one of them is the mean and the other is the median. Remember, the mean is the closest value to the tail. Well, then the first X right here must be the mean because that is closer to the tail. And just to give you a question that I put on the final exam this semester, it was this. Let me show you. Okay. First of all, can you tell me, is this a left tail or a right tail distribution?
Right tail.
Right tailed. Oh, look what I put. That's the exact same question that students saw on the final exam. And I think you can guess what the question was. Which is which? Which one is the median? Which one is the mode? And which one is the mean? And I tell students, first of all, find the mode because that's the easiest. Which one of those letters is the mode, guys?
A.
A is the highest, yes. Then I tell students, find the mean now because the mean is the closer to the tail.
B.
B is closer to the tail, I agree. And guys, it's no brainer now that you know that this is the median. And the language is already there about what I just stated. All right, so that is how you can tell. But remember, if the graph is symmetric, the mean and the median and the mode are exactly the same. You don't change anything. Okay. There's no more new stuff that I would like to do, but one more thing, I'm gonna get started and I'll have you